Geometric progression. Geometric progression is a sequence in which the subsequent term is the product of the previous term by a given constant, q. We can see the definition of geometric progression by the recurrence formula. How to understand this formula? First, we have the term a with index 1, which is equal to a value a. That means I'm defining a term to be any value. That's my initial value. Any value. Then, we can read the term a with index n. The index n is any number that has to be a non-negative number and not a decimal, as they are unique and integer indexes, therefore belonging to natural numbers, and has to be greater than 2. If not, it is not a sequence. We can read then the term a index n is equal to the term a index n minus 1 times a value q, so that every index n belongs to the set of natural numbers, and n is greater than or equal to 2. Keeping this formula in mind, we can now continue understanding geometric progression. We can have an increasing geometric progression in two ways. Let's look at this recurrence formula. We have a index n. If it is greater than the term a index n minus 1, then it implies that the division of a index n by a index n minus 1, this division has to be greater than 1. Let's say we have the sequence 2, 4, 8, 16, and so on. C. Let's say that the a index n is 8 and the a index n minus 1 is 4. If I divide the a index n by a index n minus 1, then the value will be 4, and 4 is greater than 1. As shown in the recurrence formula. For this sequence to be like this, we have that the value of q is 2. Therefore, greater than 1. Thus, every geometric progression that has a subsequent value, greater than the previous one, has the ratio between them greater than 1, and its q value will be greater than 1. In the second line of the recurrence formula, we now have negative terms. If the term a index n is smaller in modulus than the term a index n minus 1, then its division generates a number between 0 and 1. So, for the terms to be increasing, the q has to be between the value 0 and 1. For example, minus 54, minus 18, minus 6, minus 2, minus 2 divided by 3, and so on are increasing terms. So, for example, if we divide minus 18, which is the term after the term minus 54, then we will have a number between 0 and 1, and if we look for the multiplicative value, we will have the value of 1 divided by 3. We can also have a constant PG. In this case, we can have two possibilities. If the initial term is 0, then all values depend on the product with initial term, and thus all values become 0, whatever the value of q. Another way is when the values of the subsequent and previous terms are equal, so that q has the value 1. There are also alternating values. When a value has the opposite sign to the previous one, this occurs when the value of q is negative. And we still have the stationary ones. When the initial term is non-zero and all others are 0, this happens when the value of q is 0. Hello, our video has ended, but you will find much more news on our YouTube channel, Busca de Verdade, and on our website reformadoresdesaude.com. News and videos and texts with various tips on health, historical themes, archaeological, educational, principles and virtues, mathematics and physics, geography and science, methodologies, and much more. Join our channel and our website and you will see millions of topics covered there. Do not waste time. Knowledge is power. We wait for you there. Until later.